Welcome dear students. Today we are going to do the application of Cayley Hamilton theorem. What is Cayley Hamilton theorem actually explains is the Cayley Hamilton theorem statement is every square matrix satisfies its characteristic equation. Every square matrix satisfies its characteristic equation. Now here you have a square matrix. The square matrix A is 1, 1, 0, minus 1. So when you say about the characteristic equation, that is determinant of A minus lambda I is equal to 0 is the characteristic equation of the given matrix A. Is the characteristic equation of A. So let us now see what is that. Determinant of 1, 1, 0, minus 1 is the matrix A minus lambda times of I, that means lambda 0, 0, lambda, the determinant is equal to 0 is the characteristic equation. So what is this giving you? 1 minus 0, 1, 0, minus 1 minus lambda is equal to 0. Now you can find out the determinant of course, but it is easier to understand the shortcut method to find out the characteristic equation. Always start with lambda square because it's a square, it's of order 2 by 2. Your degree of the characteristic equation is 2. And then first you start with plus and then minus. Now the trace of the matrix A is the coefficient of lambda. Now the sign is plus, the constant is determinant of the matrix A is equal to 0. This is what the shortcut method to find out the characteristic equation. I hope all of you know what is the trace of the matrix A. The trace is nothing but the sum of the principal diagonal elements. The principal diagonal is 1 minus 1. The sum of them is 0. So the trace happened to be 0. So there is no coefficient of lambda. And now coming to the determinant. The determinant is nothing but 1 into minus 1 minus 0. So that is minus 1. So the value, the characteristic equation happened to be lambda square minus 1 is equal to 0. It is very much clear now that the characteristic equation is lambda square minus 1 equal to 0. So what is the Cayley-Hamilton theorem says? That every square matrix satisfies its characteristic equation. So just plug the matrix A in the place of lambda. Minus 1 means the identity matrix is equal to 0. So what is the matrix A square? Is the identity matrix. Now in the question it was asked to find out A power 6. So A power 6 is nothing but A square the whole cube, correct? And A square is already I, and I when you multiply how many number of times also you will get I itself. Therefore A power 6 is equal to I. Did you understand? So don't do A power 6 means multiplying x 6 times. By using the Cayley Hamilton, it's a very important application of Cayley Hamilton theorem to find out the powers of the matrix A if there is the trace happen to be 0. If the trace happen to be 0, then it is easy for you to write down the powers of the matrix A. I hope you enjoyed. Thank you.